Alright, hello guys. So I just wanted to make this really quick video. Hopefully it's not that long, but I want to just quickly do this one problem for systems of three equations by elimination. This is, in my opinion, the easiest way to do it. I do have other ones on substitution. But I guess it depends on your professor, whether or not they want you to use, or whether they want you to use substitution or elimination. I'm gonna do elimination for this video. If you'd like me to do substitution, you can let me know. There's also some videos that I have regarding substitution method. So if you could take a look at those, excuse me. So let's get started. So we have this problem here: 2x minus 5y plus 4z equals 5, 3x minus y plus 5z equals 4, and x plus 3y plus 2z equals negative 3. So the idea here is that you have to eliminate a variable, but you have to do it twice, so that you get a system of two equations, and then you just eliminate again to get one of the solutions, right? So I'm going to show you how this is basically what the video is for, so I can show you how that process goes. So let's say, for example, you just choose any of the variables. Typically, you would choose the one that is, or usually you would choose the one that is easiest to eliminate. So in this case, we can do our x variable. So let's just say that we grab equations 1 and 2. So let's name this equation 1. Let's name this equation 2, and let's name this equation 3. Okay, and I'm gonna go ahead and color code equations so that you guys know which one is which. Let's see. 1 second. So I'm gonna just go ahead and color code each of these so that you guys know which one is which, and that way we can just make it very clear, right? So let's grab equations 1 and 2, right? So we have 2x minus 5y plus 4z equals 5, right? And we have 3x minus y plus 5z equals 4, okay? So I'm gonna try to eliminate my my x variable, okay? Now, looking at these two numbers, we want them to cancel out somehow, right? So in order for that to happen, you have to get your, I forget what this is called, either the least common multiple or the greatest, I think it's like the greatest common, not the greatest common factor, but the least, I think it's the least common multiple, I think. Basically, you're going to do 2, 4, 6, and you're going to do 3, 6, right? So you know that they both have a common term of 6, right? They can be, you can multiply both of them so that they have a 6. However, you want them to cancel out, meaning that if I'm going to make this, so I'm going to make it so that it's multiplied, so that it's 6, right? So, let me move this. So this is going to give me, I'm going to go ahead and multiply all around. So I have 6x minus 15y plus 12z. And I'm also going to multiply by 3 on the other side, because when you multiply by 3 on one side, you have to multiply by 3 on the other side of the equal sign, okay? So 5 times 3 is 15, because basically we're just multiplying 3 on the other side as well. That's because, well, for those of you who don't understand, it's like if I say, you know, x equals 3, so that means that if I multiply by 3 on both sides, 3x equals 9, right? It's just basically that idea. If A equals B, then AC equals BC. That's the theorem behind that. So then I want to make sure that I also can eliminate. I want to be able to eliminate my x variable. So what I'm going to do here is I'm going to multiply by -2. Okay, so that gives me -6x plus 2y minus 10z, and then again I'm going to multiply the other side by -2 as well, which is going to be -8. So doing this, you notice that the x cancels out, which is exactly what I want. I want the x to cancel out. We do -15y plus 2y, it's -13y. 12z minus 10z is just 2z, but you're going to put plus 2z because it's an equation. And then 15 minus 8 is just 7. So out of these two equations, I got this equation here. Let this be new equation 1. Okay? Now I'm going to grab equations 1 and 3 and do the same thing. I'm going to eliminate my x variable. So I'm going to do, so basically here's what I did. I grabbed these two equations. So I grabbed this one, I grabbed this one, and also this one. And I eliminated. So equations 1 and 2, I grabbed those two and I came up with this equation. The only reason why I'm naming it new equation 1 is it's just another name for a new equation that we made up. You want to make it so that it's a system of 2 and then do elimination again so that you can eliminate the variable and solve for the variable. For one of the variables, that is. So, we're going to grab equations 1 and 3. So basically, let's see here. We have 2x minus 5y plus 4z equals 5. And then we have x plus 3y plus 2z equals -3. So looking at this, obviously you want to eliminate, like I said, just like we did here, we eliminated our x, right? The way that I always do these, guys, is I always do equations 1 and 2 and 1 and 3. Like, that's like the best, like, so that way you don't get yourself confused. I always do equations 1 and 2, I eliminate, and then I do equations 1 and 3. So basically, this is what I'm doing. Hold on. I'm doing this, and let me make sure that, okay. So I'm doing this, right? So, I'll just use this one. I'm doing this, right? I'm grabbing equations 1 and 3 now, and I'm gonna eliminate my x variable. So how do I eliminate it? If I have a 2x and I want to make it equal to 0, I want to cancel it out, I'm literally gonna multiply by -2 here. So this gives me the following. 2x minus 5y plus 4z equals 5, and -2x minus 6y minus 4z equals, and again, you're multiplying by -2, right? So it's going to be 6, right? And luckily, usually, I mean, this one was kind of like an easy one, because as you can see now, our 2x's cancel out. So we don't have to do it again because we already solved for a variable, if that makes sense. Like, we've already solved for a variable, so we don't have to do it again in systems of two equations, if that makes sense. So we have negative 11y is equal to 11, right? So because basically you multiply it on both sides, and you come to find that the x cancels out, the z cancels out, so you're just left with negative 11y equals 11. 5 plus 6 is 11. So you're just going to divide by negative 11 on both sides, and you have y equals negative 1. So now we have one of the solutions. Notice that here we have an equation in two variables, and one of the variables is y. So I'm going to go ahead, grab this, and plug it in here. Okay, so I have negative 13 times negative 1 plus 2z equals 7. 13 plus 2z equals 7. I subtract 13 on both sides. I get 2z equals, I think it's negative 6. And I divide by 2 on both sides. I get z equals negative 3. The last thing is you're going to go ahead and you're going to grab one of the original equations. So in this case, I would grab the x plus 3y plus 2z equals negative 3 because we already have the x. We want to solve for x, right? It's already 1 in terms of 1x. So that's the easiest one to grab. I have x, so, and I already know what y and z are. So I have x plus 3y plus 2z equals negative 3, and I'm going to just plug in y and z. So I have x plus 3 times negative 1 plus 2 times negative 3 equals negative 3. So we're just going to simplify this. We have x minus 3 minus 6 equals negative 3. Negative 3 minus 6 is negative 9. So that's equal to negative 3. To solve for x, we just add 9 to both sides. We have x equals 9 minus 3, which is just 6. So the solutions are x equals 6, y equals negative 1, and z equals negative 3. And if they want you to write it in an ordered triple, which is of the form x, y, z, you would just write it as 6, negative 1, negative 3. Okay? And that is your final answer. So, that is basically it for this video, guys. If you have any questions, please let me know. Please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.